Hi, we discussed cardiovascular changes during exercise in the previous video. In this video, we will discuss the respiratory changes during exercise. Respiratory changes during exercise. Now, it's very obvious that if the person is performing the exercise, the muscles are going to need extra oxygen, and therefore, just as CVS was stimulated, cardiovascular system was stimulated, even the respiratory system is going to be stimulated, because then it will take in extra oxygen, and it will have to throw out extra carbon dioxide that is generated during exercise. So obviously there is going to be stimulation of respiration. That's the basis for the respiratory changes. So first thing, stimulated ventilation, stimulated respiration, breathing is increased, means what? There would be increased tidal volume, normally about 500 ml, but it's going to increase the amount of air that we breathe in or breathe out with each breath. And there is increased respiratory rate, the number of breaths per minute, normally about 12 to 14 breaths per minute. That's our respiratory rate, but that is going to increase. It's going to be more than 18, 20, 25 per minute. That's stimulated ventilation, stimulated breathing, and therefore the product of these two, that is respiratory minute volume, respiratory minute volume or minute ventilation, the amount of air that that ventilates our respiratory system every minute, that also is going to increase. Normally when we have a quiet breathing, the normal minute volume is about 6 to 8 liters per minute. 6 to 8 liters air ventilates our respiratory system every minute. But as the breathing is stimulated, tidal volume and respiratory rate have increased, therefore this is going to be much higher, 12, 15, 20 liters per minute. So that's stimulated ventilation. Now the point is that stimulated ventilation, now this is going to be an important facet to this discussion. Ventilation is stimulated just at the start of exercise, just at the onset of exercise, then during the course of exercise, and also after the exercise is over. Now, we understand that during the course of exercise, when we have performed 3 minutes, 4 minutes, 5 minutes of moderately intense exercise, there will be increased carbon dioxide generation by the muscles, and that carbon dioxide will cross the blood-brain barrier, enter the brain, and it will stimulate the respiratory center, and therefore ventilation will be stimulated, and that stimulated ventilation will wash out the carbon dioxide from the body. Carbon dioxide and H plus will be washed out. That's understandable, that if you have performed the exercise for a few minutes, but how come just at the start of exercise, when carbon dioxide generation has not increased and yet ventilation gets stimulated? How is that? And how come after the exercise is over, after the exercise is over, oxygen demand of the muscle goes to baseline again, exercise is finished, then muscles don't need extra oxygen. Then how come even after the exercise is over, for some time the ventilation remains stimulated? For what? What's the purpose for it? Therefore, we need to understand these three things. First, just at the start of exercise, at the onset of exercise, ventilation is stimulated. How come? Now, this is called as anticipatory rise. Anticipatory rise. This is a type of feed forward regulation in the body, that it is anticipated that the muscles are going to need the muscles are beginning the exercise, that is contractions, and therefore they are going to be require extra oxygen, and therefore ventilation needs to be stimulated. So it is in anticipation of that the ventilation increases. So what happens is, as the cortex is sending signals to the spinal cord, and from the spinal cord to those muscles to begin the contractions, there would be also signals sent to the respiratory center and signals directly sent to the respiratory muscles like diaphragm, and ventilation will be stimulated just at the onset of exercise. Remember, we said carbon dioxide generation has not increased, yet just at the start of exercise ventilation gets stimulated. This is in anticipation. Now, during the course of exercise, how the ventilation gets stimulated? There are two reasons or two mechanisms. One is said to be the proprioceptive feedback, proprioceptive impulses from the concerned joints and muscles. You see, the muscle has started contracting. So proprioceptive impulses from those contracting muscles, they will come back from those muscles and joints, from there to the spinal cord, and from the spinal cord they are being sent to the higher centers, particularly the cerebellum. These signals also, as they are being sent up to the higher centers, these proprioceptive impulses from the contracting muscles, they can also give collaterals to the medulla respiratory center, and they can stimulate the ventilation. So this is one reason why ventilation remains stimulated during the course of exercise. At the start it was anticipatory rise, and then you start moving the joints, you start contracting the muscles, and therefore those contracting muscles send proprioceptive impulses from the muscle back to spinal cord, from spinal cord to the higher centers, particularly to the cerebellum. These upgoing signals, they can give collaterals in the medulla and stimulate the respiratory center. So ventilation will remain stimulated. And the other reason is increased carbon dioxide production. Now this is true only for a moderate to intense exercise. You know why? Because how is it that carbon dioxide stimulates our ventilation? Carbon dioxide in the arterial blood, it enters the brain. Arterial blood, as it enters the brain, carbon dioxide in that blood will cross the blood-brain barrier. It will enter the brain substance, or it will enter the interstitial fluid in the brain, or it will enter the CSF, and this will combine with water of the CSF to form H2CO3. It will split into H plus and HCO3 minus, and these H plus, these hydrogen ions will then stimulate the respiratory center in the medulla, and ventilation will be stimulated. So that is how carbon dioxide stimulates our ventilation. But then remember, it has to be arterial carbon dioxide. See, muscles are generating carbon dioxide, extra carbon dioxide, as the muscles are performing the exercise. Fine. But that carbon dioxide generated by the contracting muscle, it comes in the venous blood. From the venous blood, it will come into the lungs, and then it will be expelled out. That carbon dioxide will be expelled out. We need carbon dioxide to increase in the arterial blood, because then it will go to the brain and then stimulate the respiratory center by forming the hydrogen ions. So that happens in not in mild exercise, but that happens in the moderate to severe exercise, that excess carbon dioxide is generated by the muscles. So, this carbon dioxide generated by the muscles, it will come into the venous blood, venous drainage from the muscle, it will come back to the heart, then it will go into the lungs. Some of it will be expelled out with expiration, some of it will be expelled out, but then remaining carbon dioxide, which is the extra carbon dioxide, will come back to the left side of the heart, yes, and it will come to the arterial side. Now the arterial CO2 has increased, and now this arterial CO2 will enter the brain via circulation, while circulating, and then, as I mentioned, it will cross the blood-brain barrier, it will enter the CSF, combine with water, it will form hydrogen ions, and hydrogen will stimulate the ventilation. So, that is how moderate to intense exercise, by producing excess carbon or extra carbon dioxide, can stimulate the ventilation. This is during the course of exercise, and even after the exercise is over, this can be the mechanism. As long as carbon dioxide in the blood is little higher, it will continue to stimulate the ventilation even after the exercise is over. So, let me take the third issue. After the exercise is over, why the ventilation remains high, and what is the purpose of it, and what is the mechanism? Now, first thing, as I mentioned, carbon dioxide was little higher in the arterial blood. So, when you stop the exercise, still there is some high carbon dioxide in the arterial blood. It is entering the brain and it is stimulating the respiratory center. So, that is how it remains stimulated. Ventilation remains stimulated even after the exercise is over. Remember, what I am trying to say is significant, that exercise has stopped. So, muscles are not going to need extra oxygen now after this, yet ventilation remains stimulated. Well, how we said that there is extra CO2 and it is going to stimulate the ventilation. But stimulated ventilation means even after the exercise is over, we are taking extra oxygen. Now, why is that? This needs to be understood, that exercise is finished, yet the ventilation is higher, it remains stimulated for some time. Why is that? Because muscles don't need extra oxygen now. Exercise is over, muscles have stopped contracting. So, what is the purpose of this extra oxygen which is being taken? Now, that is called as oxygen debt. Oxygen debt. That there is some debt that has been incurred and that has to be repaid back. So, after the exercise is over, we still take extra oxygen for some time, our ventilation remains stimulated for some time. The mechanism is said to be, or the reason is said to be, oxygen debt. A debt was incurred during exercise, that debt is being repaid. Let us try to understand what that debt was. Now, let us say we were performing intense muscular exercise. We started with an intense muscular exercise. What will happen? Oxygen demand by the muscles it's suddenly going to increase, but heart and lungs cannot immediately catch up with that intensity of exercise. You can understand this. Suddenly the muscles have started the intense exercise. Can the heart rate suddenly go from 72 to 150 beats per minute? No. Can the respiratory rate and depth suddenly increase and become double? No. So, heart and lungs, cardiorespiratory system cannot immediately catch up with that intensity of exercise. But muscles, they do need the extra energy. So, how is this linking up? Two things will happen. In such a scenario, two things will happen. One is stored oxygen in our body will be utilized for the muscles temporarily. See, as I mentioned, heart and lungs cannot immediately increase their capacity to take the oxygen from the atmospheric air and deliver it to the muscle. Suddenly they cannot increase. This will happen slowly, step by step. Heart and lungs can increase their capacity step by step. But muscles are needing extra oxygen. So, there has to be some arrangement for that. Therefore, instead of depending on the external oxygen coming and being supplied to the muscle, stored oxygen in our body will be utilized. Remember, at any given point of time, we have about 2 to 2.5 liters of stored oxygen in our body. Half liter in lungs. You know, in lungs there is always some air, functional residual capacity or residual volume, some amount of air that's always there, and that oxygen is always there. 1 liter in blood, because hemoglobin is carrying oxygen, and all of it is not always unloaded into the tissues. So, there is some oxygen which is always combined with hemoglobin, and it's there as a stored oxygen or oxygen pool of the body. And half liter to 1 liter is in the tissues, you know, combined with myoglobin and other such compounds which are the temporary stores of oxygen. So, we have 2 to 2.5 liters of stored oxygen in our body at any given point of time, and if heart and lungs cannot take extra oxygen immediately at such a rapid rate, then this stored oxygen will be utilized, will be given to the muscles. Muscles need extra oxygen, exercise is intense. And two, if oxygen is not enough, then there would be anaerobic metabolism in the muscles. If the oxygen could not be provided that fast to the intensely contracting muscles, then there would be anaerobic metabolism, and as we are aware, anaerobic metabolism generates lactic acid, and hence after the exercise is over, we are taking extra oxygen over and above our basal requirement. Exercise is over, muscles are not needing extra oxygen, and yet we keep taking extra oxygen. Ventilation remains stimulated for some time after the exercise is over for these two things. One, this debt was incurred, so this has to be repaid back. We took oxygen from the stores of the body. Now this has to be replenished. This has to be repaid back. Therefore, we need extra oxygen to be taken after the exercise is over. And also, some lactic acid was generated during the course of exercise. There was anaerobic metabolism. Therefore, we need the extra oxygen to convert this lactic acid into pyruvic acid, so that it can be brought back into the metabolic cycles again. And therefore, we take extra oxygen after the exercise is over. That taking of extra oxygen over and above our basal requirement is called as oxygen debt. And remember, it is for these two things that we are taking that extra oxygen. Oxygen debt generally is, or highest oxygen debt can be about 11 liters per minute. That much extra oxygen we can take per minute, 11 liters. So, oxygen debt can be about 11 liters per minute. Out of this 11 liters, first 3 to 3.5 liters is called as alactacid oxygen debt, or rather this amount will go to replenish the oxygen stores. As I mentioned, that stored oxygen was taken, and therefore this oxygen will go for that part, replenish the oxygen stores, and remaining 8 liters will be the lactacid oxygen debt, because lactic acid has been formed. So disappearance of that lactic acid from blood will need some oxygen. So two parts, alactacid oxygen debt and lactacid oxygen debt, for those two things which happened during the course of intense exercise. This 11 liters of oxygen will be utilized for that purpose. That's the oxygen debt, and these are the changes, the respiratory changes during muscular exercise.